Hello friends, this video on equilibrium part 22 is brought to you by exampa.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. Let's understand the Haber process now. We have learned the properties of chemical equilibrium and I told you that we'll use these properties to generate Haber process, to generate ammonia using Haber process. So before I even talk about the Haber process, let me talk about the great thing about the Haber process. See, if you know that 78% of the atmosphere is nitrogen. 78% of the atmosphere is nitrogen and it is all waste because we can't directly consume it. We need ammonia because that is fertilizer, but we are not able to use this nitrogen. 78% of the air is nitrogen, but still it is waste. And the cost of production of fertilizer was very costly before 1930. That's very costly, and that is mandatory also, because if you want to produce more food, if you want to have green revolution, wheat revolution, you have to bring more ammonia. That is the main raw material for fertilizer. So what happened in 1913? This guy Haber, he developed a method to produce ammonia from natural nitrogen, atmospheric nitrogen. He found a way to convert to ammonia. That was a big thing because with this fertilizer, almost 40% of the population are fed because of this. 40% of the population in this world get food because of this Haber process, and that's a very critical process. Without this process, the production of ammonia was very difficult and the food price was very costly. Now this production of ammonia became cheap and very easy, very reliable. We can produce more fertilizers and we can produce more food actually, because fertilizers will give you food, right? So this process helps to sustain half of the world population. And to produce this whole thing, we maintain a pressure, high pressure of and pressure we mentioned of pressure. I'll just write the values here. Let me write here. Pressure we maintain 150 to 250 bar only, because we need high pressure actually, but high pressure will be very costly, right? So we can't maintain that. We want to decrease the cost, so we maintain this 150 to 250, which is reasonably not that costly to get. Temperature also we need high, but we can't go for a very high temperature because again, producing high temperature is very costly, right? So we maintain 300 to 550 degrees Celsius because producing even more high is very costly. Okay. And the reaction which we use is N2 plus H2 is 3NH3. So from here we supply N2 and H2. What will happen is, goes through catalyst. Catalyst will do what? It will just increase the reaction rate, right? So you can use various catalysts. You can use K2O, you can use CaO, you can use SiO2, Al2O3. There's a lot of catalysts in the market, or you can use the iron-based catalyst. So it goes through catalyst. Catalyst does nothing but it increase the rate of reaction so that you get product very fast. And now what happens is, there's a coolant here. There's a coolant, the cold water or coolant. Cold water or coolant is used. It will cool down things. It will cool down the ammonia, and ammonia is collected here, right? And again the other gas N2 and H2 again goes here and it is recycled, and thus you get more ammonia. How this is done I'll tell you, and now I'll tell you how we are using all the principles which we used to tame the concentration, tame the equilibrium. So now if you see, this is an exothermic equation, so it gives heat actually. So let's talk about temperature. Let's talk about effect of temperature. So what we have seen is, since this is an exothermic reaction, if you increase temperature, what will happen? The reaction will start moving in this direction, back direction, right? So equilibrium will be reached easily, correct? Since it is an exothermic reaction, if you increase the temperature, what will happen? The equilibrium will move in this direction. So what we do, we use coolant to decrease the temperature. The moment you decrease the temperature, ammonia comes out and it is collected, and again you increase temperature here. So thus, by playing with the temperature, by using coolant, we are able to get more ammonia. Correct? So we played with the temperature. Second, if you see, there are 4 moles here and we have 2 moles here. Okay. So if we increase the pressure, what will happen? The reaction will shift in the direction where we have less number of moles. That is, reaction will shift in this direction, forward direction. So we increase pressure, decrease temperature. Correct? So we increase pressure here. We use high pressure, I told, right? 250 bar. Why? Because increasing pressure will help you get more ammonia. Correct? So we played with the pressure part also. We told that catalyst will speed up the reaction. So we used catalyst also to speed reaction. Fourth, we told the concentration change, right? So to increase the reaction more, what we do? We have to take out this ammonia. If you take out more of ammonia from this system, more ammonia will be produced, because our goal is to move this in the forward direction, right? So to move in the forward direction, we have to remove the NH3. So from here, if you see, we take out NH3. So if you take out NH3 from the system, we are decreasing the concentration decrease of product. So we are decreasing the concentration of product. Thus we are forcing the reaction to go in the forward direction. And how do we separate this ammonia? See, we know that, I'll talk about the boiling point. Boiling point. So I have here ammonia has the highest boiling point, and then we have nitrogen gas, and then I have a hydrogen gas. Now, if my temperature is, let's suppose here, everything is in the gas form. If my temperature is here, this will liquefy, but this will still be in gas, right? So I'll put my temperature somewhere here. So with this, ammonia will liquefy and come down. And this guys will, nitrogen, hydrogen will be gas, it will go here, right? So that's why we use coolant to cool down and liquefy ammonia and to take ammonia out. So thus, if you see, in the industrial usage of Haber process to produce ammonia, we used almost all the features of equilibrium. We played with temperature, we played with pressure, we played with catalyst, we played with concentration, just to give maximum ammonia, just to get maximum ammonia. Thus, you see, just because we had knowledge of all the effect of temperature, pressure, catalyst and concentration on the equilibrium, we were able to get more of ammonia, and that saved 40% of the world population, right? That feed 40% of the world population. So knowledge of chemistry helped to grow more foods, grow more quality foods, and have a happy world. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.